Okay, students. So today we are going to discuss 2013 A levels Pure Maths Part B, question number 11. Question number 11. So this is the first question in the Part B. So basically, the question A part is about remainder and factor theorem, and the B part is all about quadratics. Now, generally, for this A part, you're going to be receiving about somewhere around 25, 35, 45, 45 marks out of 150, and the rest of the marks is allocated here. Rest of the marks is allocated here, somewhere around 105 marks. Okay, so it's necessary to understand that the quadratic parts is carrying a little bit more weight than the remainder theorem and factor theorem in the 2013 paper. Okay, now we'll discuss all of this. Question number 11, part A. Read the question. They are telling, let fx equals ax to the power 3 plus bx squared minus 11x plus 6, where a and b are elements of real numbers. If x minus a is a factor of fx, and the remainder when fx is divided by x minus 4 is minus 6, find the value of a and b. They are telling that x minus a is a factor of fx, which means by applying factor theorem, we can say f1 should be equals to 0. So f1 actually means wherever you have x, put 1, a times 1 to the power 3 plus b times 1 to the power 2 minus 11 times 1 plus 6, a plus b minus 11 plus 6, a plus b 11 minus 11 plus 6 is minus 5, f1. So f1 is 0, we know that, a plus b minus 5, which means a plus b should be equal to 5. This is equation 1. Then the next part they have given you that when fx is divided by x minus 4, the remainder is minus 6, which means, write that down, when x minus 4 divides fx, comma, remainder is minus 6. So now you can apply remainder theorem. By remainder theorem, you can say that f6 should be, sorry, f4 should be equal to minus 6. So f4 means that is equals to a 4 to the power 3 plus b 4 to the power 2 minus 11 4 to the power 1 plus 6. 4 into 4 is 16 into 4 is 64. 64a plus 16b minus 44 plus 6, that is equals to minus 6. 64a plus 16b equals, you get this side, so 44 minus 6 minus 6. 64a plus 16b, okay, 44 minus 12. 4 minus 2 is 2, 4 minus 1 is 3. 64a plus 16b. All of this number can be divided by 16, so divide all by 16, you will get 2 equals 4a plus b. This is equation 2. Equation 1, equation 2, you can take 1 minus 2 It's rather better if you can take 2 minus 1. So 2 minus 1. 4a minus a is 3a. B minus b is 0. 2 minus 5. So 3a equals minus 3, which means a equals minus 1. By the equation number 1, you can say minus 1 plus b equals 5. B equals 5 plus 1. B equals 6. We have successfully done the first part of the question. We have found the value of a and b. Now the next part of the question they are telling, also find the other two linear factors of fx. Okay, other two linear factors of fx. First of all, let's go to a new page. We know that fx equals ax to the power 3 plus bx squared minus 11x plus 6. We know that a equals minus 1 and b equals 6. This is the answers we got in the previous part of the question. So now fx should be equal to minus x to the power 3 plus 6x to the power 2 minus 11x plus 6. Also we know that x minus 1 is a factor of fx, which means we can long divide this. I'm going to put it this side by long division. So minus x to the power 3 plus 6x squared minus 11x plus 6. Divide this by x minus 1. So here you should have minus x squared. X times minus x squared is minus x to the power 3. Minus into minus is plus. X squared times 1 is x squared. Subtract this 0. 6 minus 1 is 5. Minus 11x plus 6, which means here you need 5x more. So 5 times x is 5x squared minus 5x. This 0 minus 11 plus 5 gives you minus 6. Minus 6x plus 6. Here you will get minus 6. Minus 6 times x minus 6x plus 6. Remainder 0. So now you can write fx as what? X minus 1 multiplied by minus x squared plus 5x minus 6. You can take minus out. X minus 1, x squared minus 5x plus 6 minus x minus 1. You can factorize this further. X times x, 3 times 2, minus times minus. X squared minus 3 minus 2 gives you minus 5. Minus 3 multiplied by minus 2 gives you plus 6. Then you can, if you want, you can put this minus back into this equation, or you can leave it as it is. Doesn't make a huge difference. Okay, so this is fx. So your question is not to find fx. Your question is to find the other factors of fx. So other factors of fx is x minus 3 and x minus 2. Done with that complete question. Part A successfully completed. For this, you will get a total of 45 marks. Now, the first part of the question is done. Remainder theorem, factor theorem part is done. Let's move to the quadratic part of the question. Part B. Okay. Read the question. Let alpha and beta be the roots of the equation x squared plus bx plus c equals 0. The roots are alpha and beta. And gamma and delta be the roots of the equation x squared plus mx plus n equals 0. Gamma, delta. B, C, M, N are real numbers. Write that also. Roman 1. Find alpha minus beta squared in terms of B and C. Okay. We can do this by first of all having alpha plus beta equals minus b over 1, which is minus b, and alpha beta equals c over 1, which is c. Here gamma plus delta should be equal to minus m. Gamma delta should be gamma delta should be equal to n. Okay. Now they are talking about alpha minus beta squared. This is equals to alpha squared minus 2 alpha beta plus beta squared. Rearrange this: alpha squared plus beta squared minus 2 alpha beta. You can write alpha squared plus beta squared as alpha plus beta squared minus 2 alpha beta, and you already have a minus 2 alpha beta here. This is alpha plus beta whole thing squared minus 4 alpha beta. If you want to know how I went from here to here, we know that alpha plus beta whole thing squared is alpha squared plus beta squared plus 2 alpha beta. So if you isolate this alpha squared plus beta squared, you can subject that equals alpha plus beta whole thing squared minus 2 alpha beta. That's all. Then this 2 alpha beta is this. This is what comes from this. Next, this is alpha minus beta whole thing squared. Now you know the values, you can all assign the values. So here minus b to the power 2 minus 4c. You will get b squared minus 4c. Alpha minus beta squared is this. Now if you look at these two equations, you don't have a coefficient here, you don't have a coefficient here. You have a coefficient b here, the corresponding coefficient of this is m. You have a c here, the constant, the corresponding coefficient is n. Both of them equals to 0. So basically this is the same equation as this, but the constants are changed, or else the coefficients are changed. That is the only difference. Therefore the roots are changed. Now they are telling you to find, hence, very important word, hence, they are asking you to write down gamma minus delta squared. Now alpha minus beta squared, if this equation corresponds to this equation, then roots of this equation must correspond to the roots of this equation, which means alpha minus beta squared is this. You can write the same thing, gamma minus delta squared. Instead of b squared, you put m squared minus 4n. Okay, this is like a pattern. You can do this. Okay, next they are telling you deduce. Deduce means a special word there, like just like hence, based on the previous answer. Alpha plus gamma equals beta plus delta. If this, you need to prove b squared minus 4c equals m squared minus 4n. Okay, if this is the case, you can say alpha minus beta equals delta minus gamma, and alpha minus beta squared should be equal to delta minus gamma squared. Interestingly, delta minus gamma squared is also equals to gamma minus delta squared. What is the explanation there? If you have x minus y squared, that is x squared minus 2xy plus y squared. If you have y minus x squared, that is y squared minus 2xy plus x squared. If you look at these two equations, those two are same. So when you square this, the order doesn't matter, you still get the same answer. So alpha minus beta squared equals gamma minus delta squared. This implies alpha minus beta is this. B squared minus 4c equals m squared minus 4n. So that part is done. Roman 1 fully finished. Now let's go to Roman 2. They are asking, show that alpha minus gamma, alpha minus delta, beta minus gamma, beta minus delta is equals to c minus n squared plus b minus m bn minus cn. Now this is a typical question, that is the sole purpose of this question is to waste your time. Okay, This is a question that is made just to waste your time. Left hand side. So if you open brackets, you can have alpha times alpha, alpha squared minus alpha gamma times minus alpha delta plus gamma and delta. Same thing here, beta squared minus beta delta minus beta gamma plus delta gamma. You can take minus out, you can take alpha out, you will have gamma plus delta plus gamma delta. Beta also take minus beta out, delta plus gamma plus this, like this. But you already know that from this part, you can see that alpha beta is C, alpha plus beta is minus B, gamma and delta is minus M and N. So what you can do is, here you can apply minus M. So alpha squared plus M alpha plus this is N. Similarly, beta squared, this is minus M plus beta M or M beta. It's better, put the English letter first, plus N. Okay, we got a new equation with alpha, beta and M and N. Now we need to convert this into C and B. If you continue this, open brackets, you will have alpha squared beta squared plus M alpha squared beta plus alpha squared N plus M alpha beta squared plus M squared alpha beta plus M N alpha plus N beta squared plus M N beta plus N squared. Okay. Then you can convert this. You have to take the terms with you have to rearrange the terms in a way. So what I'm going to do is, I'm going to take alpha squared beta squared as it is first. After that, I'm going to focus on the terms with this M on it. Okay, not M squared, M on it. So there is a M here, there is a M here, and there is a M here and here. Out of them, I'm going to focus the M with alpha and beta only. So I'm going to focus on this and this, only those two. So if I take M out, I'll write it here. If I take M alpha squared beta plus M alpha beta square, I can take M out. I will have alpha squared beta plus alpha beta square. Here I can take alpha beta out. Alpha beta out. Here beta remaining. Here alpha remaining. So I can write M times alpha beta alpha plus beta. Okay, that is the explanation. I'm doing this very slowly. Try to understand. Okay, now this part got, this part done, this part done. After this I am going to take the part with N on it. Okay, so you have an N here, N beta squared, in the, there is a part with N alpha squared. So I can take N out. I will have alpha squared plus beta squared. After that, I am going to take this M squared term, alpha beta M squared. After that, I am going to take this Mn term. So you have Mn here, Mn out, alpha plus beta, this term and this term. And finally, you have N squared. Okay. Now, you can simplify this. Alpha squared beta squared is alpha beta squared is C squared. This is MC, alpha beta is minus B, plus N. Now, alpha squared plus beta squared is actually, you can deduce it. Alpha squared plus beta squared is alpha plus beta squared minus 2 alpha beta. That is minus B squared minus 2C. B squared minus 2C. So n times b squared minus 2c here plus alpha beta is c, so cm squared here mn minus b plus n squared. So I'm going to rearrange this. I'm going to have this part first, so c squared first. I should have nc somewhere. I should have nc. To do that, I need to expand this. So let's have it minus bcm, put it in the alphabetical order, plus b squared n minus 2cn plus cm squared minus bmn plus n squared. So I can have c squared here minus 2cn plus n squared. Now you can see if you actually expand this, this is equals to c minus n whole thing squared, which means we have taken this, we have taken this, and we have taken this. Now out of this, I need b squared n first. If you multiply this, you will have b squared n. So this term should come first. If I multiply this by this, I will have minus bcm. So this is the term I want, minus bcm. If I multiply this times this, minus bmn, this minus bmn, and finally I will have plus cm squared. Then if you simplify this part or factorize that part, you will get b minus m, bn minus cm. Now I spend a lot of time to do this question. So this question's main purpose in the exam is actually to waste your time. You should be very fast in simplification, or else you should actually skip some of the steps and get to the answer, because this answer totally consists of 25 marks. You will get 5 marks for this. You will get 5 marks for this first interpretation, this one. After that, you will get 5 marks for this interpretation here, taking all of this like this. After that, you will get 5 marks for, I think, this step, like this. 5, 10, 15, 20. We will have 5 more marks somewhere down the line. So if you actually not do the simplification, you will lose somewhere around 15 marks. So you are actually racing against the clock here. So if you are actually very good with simplification, then do this question, this particular question. If you have time, yes, but if not, just skip it, for just leave some space, skip it, go to the next question, finish it off, then come here. All right, next part. Now the hardest part is finished. What comes next? They are asking you deduce that the equation x squared plus bx plus c equals 0 and x squared plus mx plus n equals 0 have a common root if and only if c minus n squared equals m minus b, bn minus c. Okay. Now deducing using the previous sum or previous answer. You have two roots alpha and beta. You have two roots gamma and delta. If we have common roots, this would tell that alpha should be equal to gamma or alpha should be equal to delta. Or else you can also say beta should be equals to gamma or beta should be equals to delta. These are the four options. If alpha equals gamma, you have alpha minus gamma should be equal to 0, or alpha minus delta equals 0, beta minus gamma equals 0, or beta minus delta equals 0. If you multiply all of this, this should equal to 0, because if one of them are equal, one of them is equal to 0. If one of them is equal to 0, the whole thing will become 0. Now this looks familiar because this is where we start the question. This part here, this part is here. Now instead of this, you can write this. So instead of this, I'm writing c minus n whole thing squared plus c minus n whole thing squared plus b minus m bn minus cm equals 0. C minus n whole thing squared equals, take this to this side, you will have minus b minus m bn minus cm, c minus n whole thing squared. So put minus inside, you will have m minus b bn minus cm. Here you go, you have the answer. Now we proved that if we have common roots, then this happens. If this happens, this happens. Okay, this part is done. Now, generally, when you have this clause, if or only if, we have to use a very small notation. Okay, we have to use this small notation, this notation, like this. This means if or only if. So I'm using this here. If or only if or only if or only if only if. Now, if you go to university level, if you study pure maths and applied maths, there you will understand the correct meaning of if only if. But in your A levels, they don't really focus on the particular clause if or only if. Okay, next part. You get this last part. The equation x squared plus 10x plus k equals 0 and x squared plus kx plus 10 equals 0 have a common root where k is a real constant. Find the value of k. Now if you look at this equation, this 10 is like b, this k is like c, this is like m, this is like n. So if these have common roots, you can use this equation. C minus n squared equals m minus b bn minus cm. Then b equals 10, b equals 10, c equals k, m equals k, 10, n equals 10. C minus 10, c is k minus 10 squared equals m minus b. M is k minus 10 bn. Bn is 10 times 10 minus c is k and m is k, something like this. So k minus 10 here, k minus 10 squared is 100 minus k squared. This cancel off with this, which means k minus 10 is here 100 minus k squared, that is 10 minus k, 10 plus k. This is equals to k minus 10. Okay, k minus 10 equals 10 minus k, 10 plus k. Then you can take minus out from one of this equation. If you take minus out here, this will become k minus 10, 10 plus k, k minus 10. This and this cancel off. Okay, so here 1 equals minus 10 minus k. Take this to this side, k equals minus 10 minus 1. Sorry, it should be, yeah, minus 1. So 11. This is one of the equation. Now if you do this way, the issue is you will get only one value of k. So there is a better way you can do this. You can take from here itself again. Instead of cutting this out, you can take k minus 10 squared equals k minus 10 times 100 minus k squared. Then you can take all of them to one side. You can take all of them to one side. Okay, now all of this will come to one side. You have k minus 10, 100 minus k squared minus k minus 10 squared equals 0. You can take k minus 10 out, then 100 minus k is remaining. Okay, 100 minus k squared minus you have a k minus 10 here. 0 equals k minus 10, 100 minus k squared minus k minus 10. You can convert, you can take minus, or if you want, you can have it as k squared plus k it should be plus, sorry, plus k minus 10 k squared plus k minus 110. Then this will be like k minus 10. You can factorize this. You will get k minus 10 times k plus 11, which means k minus 10 equals 0, or k plus 11 equals 0, k equals minus 11, which is the answer we got here, or k equals 10. Now if you cut this k minus 10 off, if you cut this k minus 10 off, the issue is you will never get this answer where k equals 10. But k equals 10 is also a positive possible answer. So instead of cutting it, you should take the whole thing, take it to one side, take k minus 10 out, and then simplify this. Okay, so totally this particular question consists of 150 marks, 105 marks for quadratics, and 45 marks for remainder theorem, factor theorem. We have successfully completed question 11 in 2013 A-level paper.